I'm just going to continue from where I stopped last time. I think I'm just gonna look into the PDFs. From our Mutlu lectures. I think I got the right ones that cover what I'm trying to do, which is a data pipeline. And like I'm not really sure what I'm gonna do or how to build this exactly. The first thing that I was thinking about is to write down the instructions on below here on this file. Like what I want each instruction to mean. Then based on this, try to use Grok or ChatGPT to figure out how to translate. What do I have to do to translate the solution? The solution of the instructions. So from 0 to 6 is going to be the OP code. So it's going to be the first, this one here. So I have to think about how to, what does this mean? I think this is part of the process of this. The point of this whole thing is to force me to clarify how it works in practice, not just the concepts. So I have to think about what does the control. I think that the first thing that I have to do is to write down what each instruction is supposed to be. So I can get an idea of like examples on my mind. Then based on that, I think it's gonna be easier. I think the first one I have to probably use a decoder. And then based on this decoder and some registers, usually I think that's always the way that it's gonna go. You have the OP code, then you have two registers here, and then the immediate here. But the thing is, like, so these ones have to be connected to multiple different registers, because obviously I think that's on the system that I'm trying to mimic is gonna be like around 32-bit registers. I'm gonna talk to Grok probably to clarify this. And this is another part that is kind of hard, because obviously each register has a name, but here I don't think I can put a label on the register, so it makes it harder. But what I think I need to do is to put the conditional or the decoder close to this one. Then I have to put like 32 registers here in parallel, and then I have to connect this to the registers. Then probably use the mux. Yeah, I think the mux with the decoder to decide what each instruction is gonna do with the register. So there's something I clarify. Actually, let me see if I don't think I put the chats there. I'm gonna put some music for myself. I think I'm just gonna listen to the responses without putting on the stream, because then I can listen to while listening to the music as well. So I'm gonna look into the things here. This is basically from the last playlist. This one is about the pipelines, and I think I'm gonna watch this one later. Usually that's how it goes with Honor. One of the, in this case I think is the Spring, so probably the Spring ones are about the data pipeline, and these ones are about memory, more memory focused. So these PDFs that I'm going to look is the ones that he makes it available here on the description. I already watched a bunch of his lectures. I was just looking into these ones to review the concepts. So one thing that I wonder if I can go page by page. Plus M P. So one thing that I think I understand better, but it's obviously still confusing, is that on each section of the pipeline, you're supposed to have registers that record that step before the other one, and that's the thing that is gonna make up the multiple instructions, allow to have multiple instructions on each clock cycle, and also allow the control logic to prevent hazards. So this is another thing that I was thinking about asking Grok or ChatGPT, which is how to build the state machine. So you need a finite state machine to determine the control instruction, the control units. I think this is going to be the hardest part, probably. This. So the finite state machine is kind of the orchestrator. It determines, based on the inputs, what is going to be the next state. And there's two types. This is also very confusing. But there's two types of state machines. I think one is the Mingli, and the other name I forgot. But one of them depends on the input, and the output depends on the input and the state. And I think the other one, the output only depends on the current state. But it's kind of confusing still to me. So I have the register to decode instruction, I think. Then you have the finite state machine that is gonna orchestrate the other parts. I don't like this. The other diagrams are probably better. This one is good to see the keyboard and monitor and other things, how it's connected. And the parts about, this is the last lecture that I was reviewing there. I think it's the previous one, the 16, is about the reorder buffer. And I think the name is interlocking to determine the out-of-order execution, or to solve the out-of-order execution. So this part is still very, it's not very clear to me. But it seems like what the reorder buffer does is it uses a register file, which is a circuit that exists on the hardware to keep track of what registers are involved in instructions. Then it reorders those instructions on the reorder buffer to execute them before they actually run. I think so. It's like speculative execution. So it's kind of like trying to predict what's gonna execute in the future, and then it uses the register file to reorder the instructions and execute them before they happen on the actual main pipeline. And then if the program takes the wrong branch, then it flushes the reorder buffer. So the reorder buffer executes the instructions out of order, and then when it gets time to commit them, it puts them back in order. But this part is not very clear to me. I have to. It's gonna be tough to try to implement this on Turing Complete. So this one is, the other ones are gonna be more clear as well. So I think that, I'm not really sure if this is the register file of the reorder buffer, the one that's showing here. Or not. And the obvious question is how to write how to build a control unit. I think it's gonna be probably a bunch of mucks. Because I think mux is the main structure that you use to create control flow. That it allows you to put a signal to determine whether or not the other signals are gonna be valid. The output's gonna be valid based on the input. I think that's probably what I have to do somehow. The biggest questions I have are around how to connect the different parts. Yeah, multiplexer select. So it is what I was thinking about. Then have register enables. This one I'm not really sure how to do it. But I think that the output of the selectors is gonna be on the register somehow. Like the parts that are very hard is like one is figuring out like how to start to put everything together. And the other one's gonna be how to debug this. How do I know if I'm doing things correctly or not? That's the parts that I'm most concerned about. Because like this type of thing is not very good to do it with the LLM. Because I don't like there's a lot of friction to go in one path and the other. I'm not really sure what it means by clock here as well. Should I put different clocks on Turing Complete and connect them onto the thing? Or maybe saying that I should go directly from the clock, like the same signal, instead of putting through the program, I just put directly a wire to these other places. That's probably what it's saying. And I would assume that here is probably a mux. It determines the control flow is connected to the mux here. And this is probably a mux as well. So, because you have like the decoder path here, or encoder maybe. There are more states and then encodes each one. This was one of the parts I was confused about, and then because I wasn't sure, I didn't remember really well if the multiple instruction architecture was like several different pipelines connected together, or if it just meant one of these pipelines, and it just means one of these pipelines. It just means that at each stage you're gonna have multiple instructions executing, because it's gonna be like an assembly line where on each cycle of the clock, the instruction from the previous cycle is gonna move one row in the pipeline, and then they're gonna be executed simultaneously. So as the instruction one is being, as the instruction 3 is being decoded, for example, instruction 1 would be on the ALU here or something like that. I think that's what it means. I think what a register file here just means is like the 32 registers connected together. It's very similar to the other example that they give there. I think maybe I should use the, I'm gonna ask, I think that it should be 8. It's gonna be connected here. How do I make sense of it? I forgot to ask how many registers you, or the size of the register to use. I think that should be the 32. Sure if I can copy and paste. Oh, yeah. The other thing I'm not really sure is like how to organize this. Kind of tricky because obviously I can only know how it's gonna look once I have the full thing, and later on it's gonna be harder to move things around. I'm concerned if I put them in parallel is not the best, and it would be better to do something else. Initially, I have to go for something like the level house. Something like this. Maybe I should use this decoder as well instead of the 8-bit later. Like one of the main problems is that there's a lot of ambiguity, and I'm not really sure what's the best way to resolve this. That's what I'm trying to think about now. I thought about using these a component that has a 7-segment display. I don't understand how this works though. If I put yeah, so if I connect here directly, uh, so it considers, but I think it's just because I have the 1 as the number there. Put 16. So is this one because it is the 5th value there. The 16 binary is gonna be only the 5th thing. So let me think about this. Because obviously, like, it's much more natural to think about the decimals instead of the binary. That's the part that I'm struggling with the most here. Because I'm thinking, like, on the example there, is not very clear as well, because they are using a decoder, and they connect the decoder directly on the register. But then when you put the value on the register, what does that actually mean on the register itself? Because I'm trying to think about like normal programs, and I think on the program, usually we're gonna think about decimals. Maybe I should look into the on this this God bolts, something like that. I should look into instructions of normal program. So the problem is there's gonna be registers. If I do so it moves the value to registers, then adds the registers. So this is the question, is when you move the value, I think that this is gonna be as if it is an immediate instruction. Then how do you... So it's moving the value from one register that it moved here. This is just the stack pointer after each function call, which is the RBP, which is like the base pointer, I think, of the stack. Then it pushes the pointer of the instructions on the stack to the RBP. Then it gets the values of the arguments, I think, based on the RBP. Or I think it's the local variables. So arguments is plus when it adds to the address, and local variables is minus. So the stack rows to minus values. So this is probably moving the A and B. Yeah. Moving A here to the stack and B to the stack. The thing that I'm struggling with is what does that mean? Like, how do I translate that on my mind into the binary so I can decode there? Because, like, how do I make sense of the values? That's the problem. Because if I use this one to decode the instruction, then obviously I'm gonna have, or actually maybe not obvious actually. Let's put this one here. Yeah, but I think it is actually how it works. Because if I put, when I put 16 there, just this one lights up. So that this means that the one here is gonna be greater than 128, I think. Maybe not. This is weird. Maybe like after each space. Yeah. So I think that each, you have to put a space to, for the thing to mean anything. Hmm. So actually, I think that I was thinking about it in the wrong way, I think. Because I don't think there is a limit to the number you put on each. Essentially, maybe I could put a decoder here and then use, I'm gonna do this test. So instead of a byte splitter, I put a 3-bit decoder, and then I use other byte splitters. And then if I do a very large number, it's gonna show there. Because I think that each space reflects one of the outputs. So it's unlimited basically. I put one here. Yeah, it's gonna be one here. Hmm. But this is the problem. Because it goes one by one, and then it fucks up everything. Yeah, this is an issue. Not sure if I understand very well. Yeah, it's just because of the way that I'm making sense of the bits. That's the problem. So the question is how to make it so that the 4 outputs are equivalent to a row, 32-bit row. So there's a different way to do it as well, which would be to use decoders on the first. Then it makes it easier to think about each instruction being one number. Like instead of doing the way that I was doing there. I'm not sure if that makes sense as well. This one. I can use all these other two as well. It's just very confusing. See what? Problem is with the LLM is not gonna be very useful, I think. Because I'm not really sure if the LLM is gonna understand the game dynamics. This is also very weird. Doesn't make sense to me. Hmm. So it overflows to 0 there. Yeah, so I think that each number is maximum, it represents maximally 8 bits. So each number represents 8 bits. If I do it this way. But it's kind of confusing if I use the decoder, I'm also not really sure what it means. They should go back to the example. Here it is using the splitter as well. It's using only one. And uses 6. Just yeah, so the star, it is storing 9 here, this instruction. What does that mean? The problem is that it could be because of a previous instruction. Trying to understand what the register means here. Like how it's gonna make sense of the value. And this is the part I'm struggling the most. Here is decimal, then here is gonna, like here is decimal, but here is bits. You have to implicitly convert on your mind to visualize the row of bits of what the decimal represents. Then based on that, it's gonna turn on just a few of them, and then the decoder is gonna make sense of what it means. Like the value doesn't matter in the context of the decoder, only what bits are turned on or off. But in the context of the register, the values are gonna matter, obviously, because that's how we're gonna do calculations. That's the part that is very confusing. Then, like, how do I make sense of the value? If I want to add like 5 to a register, I have to take into account like what's, because the decimal 5 is not going to be the same thing on the instruction value, let's say. Like the instruction could be 128, but then based on the way you decode the signals, is going to be 5 when you put it on the register. That's why it's very confusing. Let's see what Rock sounds here. Like this is another thing that is very confusing here, because if I treat them as 4 bytes, and then it obviously is going one by one here, so it's not really the same thing. Like it doesn't execute 4 bytes at a time, but I guess this probably depends on the counter. I think that's the issue I have there. Let's see if I do 5 here, if it's gonna, how it's gonna move. Yeah, so I think that's the issue. The issue there on the other one that I had is that I'm moving the clock only by 4, I think, or by 1. When it should be, I should move the clock based on the size of the row that I want the instruction should be. Now it's starting to make more sense, I think. So here, instead of this, I should move. But let's think about what it means. I think each one is going to be, if I want to represent each value as 8 bits, then obviously I need to move by 32, I think. But like I would need to move by 4. Will I make 4? Okay, 4. If I move by 4, so 4 by 4 is this. I put the, I think probably this way is the best to test this. Move this. This is the first thing that I have to make it very clear, is how does the path from, like, how do I make sense of each row of the bits here into the actual values? These registers here. You want to use this thing here, visualize. But actually, I don't really need to because I can see which ones are on and off here. I'm gonna leave it here anyway. Let's think about this. So I want each one to represent 8 bits, which is a byte. Press Alt here to fix. Yes, let's think about this. So each number represents 8 bits. That's 256 here. It should go. If I have 254 or 254, I think. Press 255 to make a full row. I don't think I need all the bits for decoding. So 255 last. Yeah, so these would be the values. So I do one number. Yeah, like this is essentially the row, and then it doesn't matter what's, because I can put the value, any value I want here, as long as. I think. Actually, I can change this. So I can do the 64 bits, actually, now that I think about it. All you have to do, because the space determines each instruction, and the clock determines the size of the row. So I could have an arbitrary amount for each one of the values that I put here. So I can put like maximum of 6 bits on the first or 4 bits, depending on the size of the instruction, of the OP code, which is how the bits are going to be decoded into instruction. Then for the registers, I can put whatever size I want the maximum value of the register to be, which I think is 64 on a 64-bit CPU. I think the instruction for each, but I'm not really sure about this. So Grok was saying that this is the RISC. This is for the RISC-V architecture, or RISC-V, whatever you want to call it, which is a simplified architecture. And it was recommending me to do this architecture because it's simpler. And the other one is probably, like, even on this one, it was saying that it requires hundreds of components to do the reorder buffer. So it might be a good idea to do. But I wanted to see if I can. Obviously, I'm not really sure if I'm going to be able to do it or not, but try to do it one that is as close to the real thing as possible to clarify all the concepts. Maybe I start with the simpler one, and then this is kind of confusing to me as well because the function here is on the middle, and it makes more sense to me for the function to be on this place here. The OP code makes sense on here. So I'm gonna ask that what on a 64-bit architecture, what is the size of, what is that register? Yeah, I'm 100% sure that actually that it's even gonna be 128 actually. Now that I think about it, I think in some architectures is 128. The R registers, the registers that start with the R, are the ones that support 64, and the ones that start with the E are the ones that support 32 bits. This is the other question, sure. Yeah, I can just put a register there. Yeah, so I can just use like whenever I use the 64, it's gonna be one of the R registers, and when I use the 32 is one of the E registers. I wanna see, so let's say if I connect this one, I'll be save here. But this is the problem, like what is, I guess it's just gonna save whatever value I have here, probably. So if I do 128 here, I think it should, it's not doing anything. Oh, it's just, yeah, so maybe here, it's gonna show there. Okay, so how do I do this? If I connect this directly here. I think it is not going there because it's going through the splitter, maybe. Or because I don't have anything connected here. Not sure. If I can do this as well. No. Weird. Oh, okay. So I have to both have the save there. I think I can do this. I just one. Yeah, that's the thing that is confusing. So I guess what I can do, I can treat each number as a 64 bit. Like the second and third here can be 64 bits. And I connect them directly to the registers. Then I use the decode to determine what the instruction means. I think that's probably how you're supposed to do it here. Not really sure though. Like it would be like this one would determine. I already have a bunch. That's so when it comes to this one, I would use this only as a control logic thing. Connect this here, this here. Maybe I think it's probably better to use the decoder instead of the, because I don't want the values to mean anything. Yeah, so now it's 188, 128 here, and the other one doesn't have anything. If I overflow, it's probably gonna be 0 again, I think. Or actually not, it's just gonna, I'm not really sure though. No, it does. So it just saves the value. So I can put like, as long as I don't surpass 64 bits in value. 64 is very hard to remember what's the maximum. Let's use 8 bits or 8-bit register. So 8 bits I think is 255, the maximum. Let me put 255 here. Yeah, then 256. And I think you have to, yeah, so 256 is 0. It automatically goes to 0 there on the command because it overflows the register, the maximum. And if you want bigger values using smaller registers, you have to decode the signal. Right, it becomes a lot more complicated because you're gonna have to split the value into multiple different 8-bit splitters, and then you're gonna have to connect all the bit splitters. Probably gonna have to sum them, I think, on a LU or something like that, so that the final value. So obviously, it's much easier to just use the 64. I do think I can do the 64 actually, and it's probably gonna be easier than I thought it would be. So like all I have to do is use. So the middle ones are gonna be the values that I put on the register, and the first one's gonna be the decoding. So this first one determines what is each solution, or yeah, what is each instruction should be. Then I increment the clock by 4. So each row goes there. And then this has to be, so the question, one of the questions is what to use as the immediate. I think it's gonna be 64 as well. What value should I use for the immediate the instruction? I think here it's probably better to, I'm not sure actually. I'm not sure. Makes sense to do this. Yeah, I don't think that makes sense to use. Hmm. Like, intuitively to me, it makes more sense to use the splitter because it's easier to think about the decimal values. So like for the first number, I could think about the decimal, and then use a 8-bit splitter to think in my mind as I build the circuit what each value is gonna mean based on the decimal value that I have there. Like when is each thing gonna be turned on to mean what I want it to mean? But I'm gonna ask you this, to Grok. I'll be right back. I think that this is one of the main things that is confusing me, because I was remembering I forgot the name of there's a software for reverse engineering that you can put executables on, and then it shows the instructions in assembly, and it shows each row of the instruction. And on that software, it shows the row in binary or in bytes. So for 64 bits would be 8 bytes each row. And it goes with what Grok is saying here, that each row would be 4 bytes on 32 bits instruction. But on the actual Turing complete here, because it's decimals, I think it's different. So you don't really think about each row here as being, like, each value as being one binary, but because the value is a decimal, is different. So I think I can, the way that this changes is that for 32 bits, I don't need to increment by, I'm gonna try to do 64 instead of 32, even though it might be more complicated. But I can do 64 bits and increment the counter by 4, because each instruction is not, like, each value is not limited to, is not represented in bits, it's represented in decimals. That is the thing that is confusing. Because if each one of these values was a binary, then I would have to increment the counter by 64. I think. Yeah, 64 bits, and which is 8 bytes if I want 64 bits. Which is basically what ChatGPT is saying, or Grok is saying for 32. So this is why it's confusing. I'm incrementing the counter by 4, but it's actually not really 4. It's not 4 bytes on the thing, because each value doesn't have. So yeah, I think that this is an issue with the game, actually. Like, if it was to be realistic, it shouldn't be. The value in bytes here should represent the value in the rows here. But I think it's understandable, because they probably made a compromise in order to be able to show the values in decimal. So I think I kind of get it now. So for me, what this means is that I'm going to increment by 4 bytes each thing, actually 4 bits, in order to have each row. But then each row is not going to be 4 bits. It's going to be more than 64, actually. This part I'm not really sure. The thing that I have to answer is what is the maximum value that each register should have. I think it's 64. But if it is 64, then that would mean that the size of each row should be bigger than 64 bits, obviously. Because I'm imagining each row as being an instruction. So if each register takes 64 bits, then obviously the row would be at least 128 bits. It doesn't make sense. Let's see if Grok says something about this. But this is another thing that's confusing, which is he's basically saying to create the like put another 32-bit register to decode the instruction. But it's kind of confusing because I think here I already have this component. Not really sure if this are actually this one. If this should be the one that I use there. But then like how does it make sense? Because it's just one value here. It's basically a decoder. Yeah, but this it doesn't take into consideration the value there. That's why it's confusing as fuck. I guess so it does matter, maybe. Hmm. I guess it depends on the way that you do this decoder here. Like if I change, obviously, if I connect different values of the splitter into the decoder, then the decimals that I choose there for this component changes. So I think that it's probably better to do, instead of using the component, to actually do the gate manually. Just put these components here on the other one instead of using this one. Then it's gonna allow me to think about what does the decimal value mean. And I think what it's saying there is put to store the value on the register, on a 32-bit register. So I would do the decoder, this decoder here. Then the outputs. But this is another thing that I'm not really sure. Like maybe you should just put the value directly into a register. Yeah, I think that's probably what I should do. Because on the like the decoding part comes on the other, I think maybe. I think each row should be each section here has to have its own register to remember in order to have multiple instructions at the same time. You should probably put directly the value directly on the register because then it encodes 32-bit opcode of the instruction. Then on the next section, I use this decoder to figure out what it means. I use a splitter to get the actual value from the decimal into bits. Then I use the decoder to choose what the decimal is gonna mean, I think. And this is all the first part, I think. The question is like, what does this path here look like on the instruction to the register? This register, so I should have, and this is probably on the thing that I'm trying to build. There is gonna be 64, so 364-bit registers. But I think that I understand. Like so this path here, it should be basically this, and I determine like the outputs of this gate here are the ones that I connect to the register here. So depending on the value, I think I get it. So this would be the decimal value. So this is obviously like it's a subjective decision that the person creating the design of the hardware selects what the bits are gonna mean, what the instructions are gonna mean. I could just put like this here. So I can do the OP codes, maybe maximum 7 decimal value. And then I can use all I don't think I understand this one very well. Obviously, like I understand what the gate is. It's basically just a bunch of ends connected to both the real outputs and the so like the value and the not of the value. So get the value and the not of the value of these 3 bits here. Then you put a bunch of AND gates and you connect the AND gates based on all these combinations. So basically it's combining all the inputs into outputs. So, but the thing that is kind of difficult to think about is like, what does it mean? Like the full scope of the decimal from what actually happens on the circuit after. That's the part that I'm not really sure. Because it's a lot easier to think about if I connect the splitter directly to the thing here, because then I can just think about the decimal. And I'm not really sure about this as well, the load here. I think load is going to be to read from the register. So based on this, like it would be connected to the loads of the register, maybe. Or maybe I need like a. This is like it's kind of unclear what this is supposed to be here. So maybe I should connect the load directly to the ALU, but I don't think that makes a lot of sense. Hmm. So it's basically just a combination of the values. Yeah, I guess it's confusing because I have to think about I have to think about what I want each instruction to be first. I think like first I have to think about all of the instructions that I want to have. Then I need to think about the gate, how to put the gates, for each one of the instructions, and how are they gonna look into the register. And we need to think about like the variance of the amount of instructions I can have here is gonna depend on the outputs that this gives here. This has 4 instructions and has 2 inputs. I have 3 inputs, it's gonna be 8 instructions, I think. Can have. Yeah, so if I can create a table. So probably like research all the instructions that you have on the CISC. Then based on that, I have to figure out like what is the variance of outputs I need here. Then based on that, I figure out how many decoders to use. And then the amount of decoders obviously is going to be equivalent to the amount of outputs you have here. And then based on that, I have to map out what each decimal is equivalent to. Like what each decimal is going to turn on the output. So I can think about what the output is going to mean. I think it's still very hard to think about. The other thing I can do is go into the component manufacturer, or component factory here. Then I create another one of this. Because I think what this does is like it allows you to put the value here directly. So that's gonna turn on based on the value there. Yeah. So like here's 255. So what's gonna happen internally is that's gonna make both of them go on, I think. And that means that's gonna be the 4th. So here's the 1st. Let's all them so maybe there on the I don't understand this very well. Maybe on the actual components there, this output is actually the immediate one. Not really sure. This here is basically saying that the condition is going to be turned on, but then here is turning on this one. And this one is the immediate. Oh no, it's because it's receiving 0 here. Yeah, so if I put 255, it turns on the other one. That makes sense. But the other thing to think about is how. So first I have to figure out, clarify what are all the instructions I want to support. Then I need to clarify what does it mean? How do I translate that signal into the registers so that they know it's both the registers and the ALU. This part is kind of confusing because I'm not really sure if the instruction is just the decimal or the value. Like if the instruction is the decoded value, I think it is actually. So like this label here, the instruction here, this is just the bit that you get after decoding through this process here. So essentially, you get this byte here, which is in decimal. You get this value, which is in decimal. Then from the value, you decode, and then you write down what each one of the bits is supposed to mean. Let's say here's going to be the immediate, whenever this output is turned on, because you determine that this is supposed to be the immediate. So from this thing here, which is the output of this, is going to be the equivalent of the output of this. So this conditional thing here, like this wire here that connects the instruction to the other registers, should be the output of these things here. I'm pretty sure that's how it's supposed to work. Then the question is like, how should I connect this to on the register? And I think that I need other circuits. Yeah, this is the part that I'm gonna have to, because each one is gonna mean something. So it's obviously up to you to make the bit mean something, mean what it's supposed to mean. I think from the output here, I need to figure out, I need to put more gates. Then I need to go over each instruction, what I want the instruction to mean. Then based on that, I have to put other gates and then connect the gates to the registers so that they have the effect that I want. Then you put other registers that are going to be connected. So the load of these registers here, I think, are going to be connected to the output of the other registers. Hmm. Stuff because it's kind of ambiguous what it means here. Because when translating to the game, it could mean different things. I'm gonna continue to read the ChatGPT response. I'm gonna stop here, and I might talk to Grok a little bit more to clarify this. So the next time I'm just gonna continue from this point here. I think it's becoming more clear. But based on what I said to Grok here, doesn't understand how it works because I described in the wrong way before. So I'm gonna describe in the right way probably. But what I'm thinking about doing is these middle inputs here are gonna be directly what I save on the register. I have to clarify what each stage means on the pipeline when it comes to the game here. Because I'm not really sure if I connect this directly, then if this would be already the decoder stage done, or if I need more gates to represent the decoder. Yeah, I think that the program component already does this instruction memory part. Yeah, so this would be like the instruction memory. The clock is the one that I put before there. So like this step here is already the first one here. This is the two register that I have there. Yeah, so this part, like this first input here is gonna be the one that goes in the control unit, I think. And the other ones in the middle are the values that I put on the actual registers. And the immediate, I think, is the one that goes to the sign extend here. That's what I have to clarify. So the output of this goes to the control unit, which has more wires probably to connect with the other parts here. There's another part that I have to clarify. I have to clarify the connection between the output of these registers and the other ones. These other two here. I think the load is going to be connected to the save on the other one, maybe. And the value, like something. I think I have to use 64, maybe. If I use 64 for this, I think it has to be 64 for this. I'm not really sure if it's something like this. Like this is going to be the read register, like this RD1 here, and the other one is A1. So it basically stores the value. Not really sure if that makes sense. Because I don't know what the load means here. I think load means to read the value. So that's what I'm applying. So it signals when you should read the value. And then the one, yeah, not sure. So I'm going to stop here. Next time I'm going to continue to just clarify. I'm going to try to build the full pipeline. I'm going to build the simplest way possible first. Try to build the simplest way possible and verify if the output is correct or not. And if I manage to do that, then I'll try to iterate to make it more realistic as possible. So see you next time.